The notion that there's only a single answer, that there's only a single solution to any given problem or question in science is probably the most damaging idea we have.
And that was Stuart Firestein, a neuroscientist at Columbia University and author of It Could Be Otherwise. It was built entirely around one extravagant idea that the deeper science gets, the less certain it becomes. And that's good news. So most of us grew up thinking that science is a machine producing answers. And somewhere out there is this final fixed truth that the job of a scientist is to just go and find it. Now, today's guest says that's not just wrong, but it's one of the most single damaging ideas that we have about how science works. And honestly, that's one of the biggest threats to science, is that there's only one right answer. So I'm Autumn Fnav, and join me in this episode of Breaking Math. Stuart, thank you for coming on the show. You open the book by making what you call an extravagant claim, that uncertainty isn't a weakness of science, but its defining feature. That's probably the opposite of what most people learned in school. So how did we end up telling the wrong story? And where is the original meaning from the book?
Well, that's a big question.
Of course.
And of course, I admit that it's an extravagant claim because it does seem to go exactly the opposite of the way we think about science, the way media portrays science, and indeed the way we teach science in schools today, where we still teach, I think, a very old brand of science, this kind of deterministic science made up of immutable rules and laws and things of that nature that nature obeys and from which we can make predictions. And so, at least in theory, whatever uncertainty we do experience is just a lack of knowledge. It's uncertainty that comes from, if you will, our current level of ignorance because we don't know the full reach of this law or that law. We don't know every law, but we could. We could. It's all law driven, and therefore we could. And that's kind of the myth of science, the current myth of science. And it's been that since science kind of, or at least modern science, what I call modern science, kind of began in 17th, 16th century, early 16th century Europe, but has now spread globally, of course. So, and that myth persists not only among students and teachers and the media, but frankly among many scientists. And I think I guess I wrote the book because I think it's a problem, because we have begun to realize that while there are islands of predictability, there are places where things remain okay and you can predict them and there is certainty. They're actually the rare points. They're the rare places that we've exploited over the years. But this all rests on a vast kind of uncertainty, which is a good thing. We can talk about why it's a good thing in a bit if you want. But I think the reality is we're learning that all of these predictable places still rely on a kind of, or don't rely on, but sit on a sea of vast uncertainties, randomness even, and probabilities is the best we can ever do.
So let's take another step back here. So if someone asked you, what is science, in just one sentence, how would you answer that differently today, even after writing this book, than it would have been maybe 20 years ago?
One sentence, huh? Not
You
sure.
can give a longer explanation if
Okay.
you want, but
Okay. Well, one sentence would be good. I just may need to think this through very carefully to get one sentence. Um, I would say that science today is it's still the best mechanism we have for understanding the world around us, for searching that world, but that it now recognizes in its best incarnation that the best it will come up with in most cases are probabilities and not final solutions. And in fact, even better than that is it may come up with more than one solution to a particular problem. The notion that there's only a single answer, that there's only a single solution to any given problem or question in science is probably the most damaging idea we have now. That's more than a sentence, but you know what?
it's more than a sentence. but that's kind of thorough because it gives us this question: has the general public confused confidence with scientific certainty in that
Yes,
case?
yeah,
Okay,
there's a lot of confusion out there, which is, of course, a problem. And I think at least part of the source of the current suspicion or disdain for science among large segments of the public, it's responsible, I think, for a certain amount of the mis and disinformation that we see coming out a lot now. Um, because there is this expectation that science knows an answer, that when we need an answer, we go to science, we find an expert, and we get the answer. I mean, that's the way it worked in school, right? You took a test, there was a multiple choice question, and there was one correct answer. That's not really the way you ever experience life, I don't think, where you have a problem, you think, well, there's 4 or 5 ways this could go, but there's only one right one, I'm sure. Well, that's rarely the case, in fact. There's a right one in this context and a different right one, perhaps in a slightly different context. And so there may be multiple solutions to a given problem. I could give you examples of that if you'd like, but
please
oh,
go
all
right
right,
ahead.
okay. So my favorite examples come from biology because I'm a biologist, and because so much of, I think, sort of what I call popular science. I don't. I mean that in science for non-technical sort of audience uses physics for some reason. Other quantum physics, everybody loves quantum physics and things like that. So I try and use biology. So I'll use an example from biology. Um, Many of us are familiar from at least high school biology of what's called the Linnaean system. This was put together by Carl Linnaeus, a Swedish biologist, many, many years ago. And this is the familiar, kingdom, family, genus, species kind of thing, is more gradations than that. But so when I say you're Homo sapiens, we know that that means you're a person, and Homo is the genius and the genus, and species, and sapiens is the species. So Homo sapiens, genus, species. This is known as the binomial classification. And we use it all the time, right? So dolphins are Tursiops truncatus or some, all these sort of things, right? So we use these regularly. Now, the thing is, that whole system is based on the idea of completely unchanging species, which is what Linnaeus believed in his day, which would have been 1600s, that the species that are here now are the ones that were created in the original creation, and that they don't go away, and there aren't new ones made, and that they're quite stable. Along comes Darwin, and now we know that's not the case, that species go extinct, that new species arise, that species are actually quite dynamic, that they change a lot. But that doesn't stop us from using the Linnaean classification when it's useful. And we do. We still classify species because over a long period of time, they do tend to remain stable. And so for many things, we can continue to use this Linnaean classification, knowing that it's wrong because it depends on stable, unchanging species, and yet we use Darwinian evolution. It lays just on top of Darwinian evolution quite comfortably, where we recognize that the crucial thing is dynamic and changing species. So we have two solutions to the same problem.
You make things in biology look standardized, right? But you have your book titled as It Could Be Otherwise, which I'm going to say because it's a math podcast.
Yes.
It sounds a bit more on this mathematical sense to me. And it suggests that a branching universe is also giving us a, all these possible outcomes
Yes.
instead of one predetermined future. So, do you want to tell us a little bit more about that in that
Yes,
case?
I mean, and this is the book was originally going to have the word optimism. If it wasn't, that wasn't the title, it was
Okay.
going to have that as the title, because of course what I believe is that all this uncertainty is tremendously optimistic because of the possibilities that it presents. So I'll unpack that just a little bit. I think science is an extremely optimistic pursuit, maybe the most optimistic thing people have ever figured out how to do and how to play around with, because it believes in progress and in possibility. Um, there are more possibilities when there's greater uncertainty than when there's nothing but certainty. So we may think we like the idea of certainty, and that we just want to know where things are going. But actually, that's kind of depressing if you think about it. I mean, if it really has all been figured out, if everything's just ticking away like a clock since the Big Bang or the moment of creation, whatever your beliefs might be in that, but it's all predetermined and it's perfectly certain. Well, that's kind of boring. I mean, we may not know exactly where it's going, but only because we're too ignorant to know. Um, so at the moment, but we could know. But it's even better if it's mostly, as you put it, this branching universe where there are these moments where things branch. They could go this way or that way. And even if the probabilities are high for one way versus the other way, this being a math show, I'll do a little tiny bit of math, right? So even if you have, so you have a bifurcation, they call it, right? A branch in the pathway. And even if you have 90% goes A and 10% goes B, okay? And then you go on for a while, and then you have another branch. And again, it's 90%, 10%. And so you always bet on the 90%. But as you know, probabilities multiply, and they're really decimals, right? When I say 90%, that means zero point 0.9. It's a number between 0 and 1. So 1 being 100% and 0 being bupkis. But 90% is zero point 0.9. So if each of these probabilities at each of these, we call them bifurcations, but each of these branching points is zero point 0.9, even though it's a very high probability, at some point you're multiplying all these zero point 0.9s together. So zero point 0.9 times zero point 0.9 is already 0.81. It's a little less, right? And eventually it gets to be quite a small number. And what you wind up with are a large number of possibilities, all of which have a low probability of occurring. And so you have a fundamental kind of uncertainty. I mean, you can, the path it took was in some ways deterministic in that it obeyed laws. I'm not suggesting that uncertainty means that the laws of physics don't matter, that they're not true or any of those things. So many of these things, you can put together a bunch of deterministic equations in a system, but loop them back on each other where, the result of one goes back into the other one and that changes the way it goes and so forth. And then pretty quickly you have a very complex network where the outcome is in the end uncertain, because there are too many possibilities, each of which has a very low probability. Does that make sense? Have I
Yes, it
gotten?
does.
Okay.
So essentially, is probability the language of optimism?
Yes, absolutely. Absolutely. You're exactly. Now, I should point out there are two probabilities, and I think this is a matter of considerable confusion. So this is exactly the right place to straighten that out. Okay, since we're
Good.
since we're
I was going to
talking.
actually ask about that, but I'll let you
Okay,
explain for yourself.
so probability is, I think, one of the great intellectual achievements of all time. I mean, in mathematics, especially, I'm sure mathematicians would tell you calculus or algebra, these things and all that. But for especially in our everyday lives, probability is quite a remarkable thing, which most of us use, even unknowingly, more than we use any of the other branches of math, probably day to day. And to come up with probability, to recognize that things things aren't always exactly calculable, that there are confidence levels and things like that is quite remarkable. So originally probability, I mean, it was developed in many different places, but in Western scientific terms, I guess, in modern scientific terms, the original probability was about gaming. And then also governments took it over to figure out mortality rates and how to tax people, of course, and all those sorts of things that governments do. Um, but those probabilities were based on a deterministic idea of the universe. So the notion was, okay, we don't know this law yet, but we see there's a tremendous regularity in something. So there must be a law underlying that regularity. We don't know it, but we can see the regularity and we can predict it in some way. So the easiest example of that is the average height of a population of, I don't care, X. And you'll get a bell curve, of course. So we don't know exactly what governs the height. We don't know why some people are 5 feet tall and some people are 6 or 7 feet tall. But we know they're going to be in a range between about 4 feet 5 inches and 7 feet 5 inches. Those would be the real extremes. And we'll see this very predictable bell curve of heights. So the thought was that if there must be some law underlying height in a population, and one day we'll find it. In the meantime, we'll use this fudge factor, which we'll call probability, right? And then an entire branch of mathematics grows up around this probability, around these curves, which eventually becomes statistics as well. So statistics really comes out of probability with a little calculus and some other fancy math attached to it, right? And statistics, though, the word statistics comes from state, right? Status, static. So it looks at something that is apparently static and tells you how likely some new case is to fit into that static curve, that static distribution, I guess would be the thing to call it. So that's the original probability. And that probability just takes new information. First, it takes a lot of old data and makes curves out of it, or makes, so they could be exponential or they could be bell curves, all sorts of different curves that you can have. And you treat them mathematically, and you can figure out how often something is likely to occur. And then you take your new data and you see how closely that approximates the old stuff. And that tells you whether your data is normal or whether it's out on the tail somewhere, what your confidence in that data might be, and so forth. So that's probability. Probability one, I like to call it. Now there's a newer kind of probability as well, which is the probability I'm more interested in. I call it sort of probability two. And that is developed, I would say, I'm not perfect at this history, but I would say in the last 100 or so years, maybe 150 years at best. And it to some extent arises with quantum physics and the probabilities that go in there, but also with biology and genetics and the probabilities associated with it. And it's a probability that actually describes the fundamental characteristic of the universe as being probabilistic. We'll never get to zero or one. That there's no such thing as that. And so this is now a probability that tells us the likelihood that some future thing will happen or not happen,
Sure.
and to what extent we can have confidence in that.
So are we looking at things like just probabilistic thinking in general, or I'll just jump to the hot spicy topic that everyone wants to talk
Yeah.
about is AI and its
Okay.
probabilistic thinking for answers. We know that that's machine learning algorithm,
Yes.
but is this on the same basis?
So I think it's a little different. I don't think AI does probability too. I'm not an expert in
Okay,
this area, but I think AI, what it's really good at is probability one. It has this vast storehouse of data in which it then, on the basis of that, makes predictions about what's about what should come next, what's the next thing, what it is you're really looking for, what it should tell you to do, et cetera, what move it should make in a chess game or the Go game. But it does this based really on past past data, vast amounts of past data, and then predicting as best as it can from that. And because I think it has so much data, it's able to it's able to make correlations that almost look like causation, right? There's the old
sure.
correlation causation business. So I don't think AI gets to a cause because it doesn't need to. It doesn't really care. It's not looking for a cause. It's just looking for sufficiently high correlation that it's pretty good at predicting the next thing. And, sometimes, I mean, your spell checker, you have to check very carefully because sometimes it makes some pretty ludicrous mistakes, right?
Of course.
Some of which are quite fun, I must say. I gave a,
They,
t- yeah,
yeah, they get very interesting at times.
I gave a commencement speech a couple of years ago at Columbia, which is where I work, for the School of Continuing Education, which is sort of a come back to
Yep.
university and get a degree. And these kids were graduating from the School of Continuing Education. So I had to write this speech up. I was the keynote speaker and all that. And I started off by saying, I titled it School of Continuing Education, but I made a spelling error, and the spell checker changed it to the School of Confusing Education, which I thought was much more appropriate. And that became the title of the talk. And the whole talk was about how the university is here to confuse you. That's what it's supposed to do. And you should be more confused now than when you got here, but in a much better way, at a much higher level than your earlier confusion. So I thought it was brilliant, right?
I have to say that probably is one of the most brilliant talks because
Yeah.
education and higher education teaches you everything and nothing.
Hmm. Yes. And really, its purpose is you should leave much more confused than you were, but at a much higher level of confusion. I mean, there's all levels of
Yes.
confusion. You can be just really dumb and confused, or you can be confused in some very sophisticated way, right?
Right.
And that's the trick. So I think AI uses a kind of probability one. And one of the questions, I guess, about AI that one could have in this issue of will it become conscious? Is it already conscious? Does it have agency and all the rest of it is when it's able to do probability two, when it's able to recognize, and maybe it does, I don't really know, because I don't know the innards of it, but maybe when it's really able to recognize that everything we do relies on probability, that the world is a probabilistic place full of all sorts of alternatives. Because AI tends to deliver kind of one answer to you, unless you keep probing it, which is what you should do, of course. But always gives you a really nice pat answer. And until you read it over two or three times and realize, well, actually, we could go a little deeper in that, or maybe I could get another answer, then you can get it to give you a sort of another answer. But it won't do it on its own, I don't think.
That makes me really think about why science actually creates some sort of better ignorance. You talk about that a little bit within your book, right?
Yes.
So when you've spent decades mentoring scientists, exactly what separates someone who asks transformative questions
Mm.
from someone who only solves existing ones? How does this
Yeah.
make us better, like question askers?
I mean, that's a really good question. I have to tell you that I don't have a perfect solution to, except that to say the interesting thing to do is to look for a question, not to look for answers, and that's the hardest thing to get students to do in a laboratory in a science situation.
Of course.
Yeah, because they seem to get rewarded for the answers. They get a paper. It's pretty hard to publish a paper full of questions. No journal seems to want that, even though it would be infinitely more interesting for us to read those things. And it is true that when I go to a conference, I go to some science conference in my field. I go to a couple of the talks, but none of that really interests anybody because it's all about the stuff we know. What do we do? Right after the talks are over, we head for the bar or the cafe. We either get coffee or drinks, depending on the time of day.
Yes.
And yeah, and I won't talk about what times of the day it is. Depends on the conference you go to, I have to
It's
say.
5 o'clock somewhere
That's
has
right.
been the new
That's
policy.
that's right. That's right. Um, and then we just talk about what we don't know. I mean, I never talk about what I know to other scientists. I only talk about what I don't know. They don't care what I know, and I don't care what they know. We all know what we all know. We've
Right.
published it, right? It's out there. What we want to know, what we want to talk about is what we don't know, how we're going to figure that out, how we might get to it, and what will happen if we do know it. What are the better questions that come out of it? I mean, every answer, I think George Bernard Shaw actually said this, and others have said it as well, but I think Immanuel Kant as well, just to throw some names around. Anyway, every answer in science begets 10 new questions. And that's the best kind of answer you can get, is one
Of
that,
course.
that gives you more questions than you started with, right? Um, but getting students to relax with that idea, getting scientists in general to relax with that idea, to recognize this is the real power of science, is its ability to ask questions and better questions. That's tricky. I think there's a great line from I never remember. Oh, Enrico Fermi. I'm pretty sure it was Fermi who told his students. I could have it wrong. I'm pretty sure it was Fermi who told his students, if you do an experiment and it proves the hypothesis, you've made a measurement. If you do an experiment and it doesn't prove the hypothesis, you've made a discovery. Now, it's important to realize that science is made up of both measurements and discoveries, and they're both important. But it's always nice to have a discovery, right?
Right.
Yeah, because it's when something doesn't work that you have new questions. That's when the new questions really come out, right? Yes, so better ignorance. That's what we're looking for.
With better ignorance, you also look at authority and why authority isn't enough. So, one of your first cognitive principles in your book actually renounces authority. So, it makes me think a lot more that this is almost anti establishment, but science obviously relies on expertise. So, how do you balance that skepticism with that expertise?
Yes, it's a tricky balance, and it's the hardest one, maybe one of the hardest ones that I think scientists and society has to do. Because I do think expertise is important, but we all recognize that experts disagree. And in point of fact, I think what you'll find is I'm not the first person to say this. I'll tell you who did in a moment, but that experts are the most uncertain of all people. The people who are the most expert in a particular field are the ones who are most uncertain about that field. So if we
Of
take,
course.
yeah, because they know where the holes are, they know what we don't know. They know the things that are still out out for question and things like that, and things that only work part way but are kind of right. And they know that we'll revise all these things. So expertise is a matter of uncertainty. Then I guess what I think the difference between expertise and authority is that authority never seems to be uncertain. Authority just tells you what is. It's the state, the church, if you will, Aristotle. Here it is. This is what I figured out. This is it, or this is what we should all believe. And that's the end of it. So I like to use a quote from Francis Bacon, who was one of the maybe the founder of sort of modern science in a way, um, who says, and I don't want you to think I've read all of Francis Bacon because it's pretty dry stuff and it's very
Fair.
thick. Yeah. But I happen to be lucky enough to pick up this one section of it in this quote, which I'm paraphrasing slightly because there's a little more to it. But he says essentially that previously truth came from authority. Henceforth, authority will come from truth. And I think that's an incredibly big statement in a very few words. The idea that we still have authority, but that it comes from knowledge, that knowledge doesn't come from authority, doesn't come from pronouncements. There has to be something behind it. There has to be evidence. There has to be expertise, if you will.
So, in that case, what does healthy scientific skepticism actually look
Hmm.
like? Because we have all of these views here that are constantly challenging each other, and we don't know what we don't know. But if
Yes.
you're an expert, you're niche down and you have your blinders up.
Yes. Yes. I mean, this is a problem for expertise. I mean, a good expert doesn't do that. There's a famous, I don't know how famous it is, but there's an anecdote about Harry Truman, our former president Harry Truman, probably the least colorful president maybe we've ever had. So not so many anecdotes about him. But he was the first president to have a science advisor at a very high level, almost cabinet level. I think inherited from Roosevelt. Anyway, yes, we could use more of that. Obviously, we could talk about that in a bit as well.
Yes.
Um, but Truman had the science advisor and was at one point heard to exclaim that he would like somebody to find him if they could, a one handed scientist. And the reason was that he would get this whole explanation from this scientist, at the end of which the guy would say, on the other hand, and give him a whole new set of ideas about it. So, but of course, that's should be seen as good, right? The fact that experts disagree, that even the same expert may have two pretty good explanations that don't exactly agree with each other. The question is, do we see that as a negative or as a positive? I'd say we see that as a positive. We should see that as a kind of flourishing. We're lucky to have two good answers. Okay, it's tricky. We have to decide between them. One's going to be good here, one's going to be good there. How long did physicists fight about whether light was a wave or a particle? Till they finally decided, you know what, it could be both, and we'll just use it as a wave when that works and a particle when that works, and that works. And so that's the nature of it. I mean, it's neither one nor the other. It's both. Whatever it is, that may be a little hard to get your head around, but in point of fact, it's very useful. And we're lucky to have two very complete descriptions of light. One is a wave and one is a particle, both of which are perfectly consistent, although incommensurable with each other. That's great. I mean,
It
we should
is.
we should be thrilled.
So in that case, we do have a lot of various opinions here. Do you want to go into like that science advisory a little bit more, or I'm
Sure.
curious.
All right. So I should say one thing just to clarify the last part of that,
Sure.
of having multiple answers or multiple possible answers to a problem. So this is what philosophers of science, at least call pluralism. And they've thought about this for decades now. So for them, it's a little bit of old hat. But I have to say, when you say pluralism to a scientist, they look at you with completely blank eyes. And they think, well, is that relativism? Or is that interdisciplinarity? Or is it diversity? Or what are we talking about here? And it's none of those things. So, so pluralism is the idea that you can have multiple solutions to a single question, even if those solutions might be incommensurable in the sense that they don't really coexist well. This was an idea that was, in my opinion, developed in its best way by a philosopher named Isaiah Berlin, who lived through the 20th century mostly, is when he worked. And so his claim would be he was more of a historian of ideas than of science, but his claim would be so, for example, there's liberty and there's security. Now, we think both of those things are good ideas, but they don't always coexist so well. So sometimes we have to make decisions, but we should be happy that we know about these two things, liberty and security. We should see this as flourishing. Okay. The problem is this just a kind of fancy relativism where anything goes? And the answer to that is no, not anything goes. But why not have more than one thing go? Why does it only have to be one thing? Why do we always have just one winner in science? That's ridiculous.
Yep.
We could have, you know, first, second, and third place, or three first places, or however you want to work it. So we have to make choices. It's our responsibility with these multiple possibilities to make choices. But we should be, again, quite happy we have choices to make because in a deterministic universe, we're not making choices.
I think that brings a good point for us and where society is headed as a whole with science, right? Because
Yeah.
we're entering this age where almost everything must have a definitive answer, and where every important decision also involves a fair amount of uncertainty, which is where society is finally catching up
Uh-huh.
in one sort of another. Do you find that that's an accurate statement, or is that where scientists have always worked in that gray area of uncertainty?
I don't think scientists have always embraced uncertainty. I think
Okay.
they've dealt with it. They've accepted it. Again, as a kind of so. I don't mean to throw these sort of words around now. This is some touch philosophy, but a woman named Marina Dubrovna, who does a lot of work in this area, sort of put it this way to me, and I think it's quite right, which is you're going to have an epistemic uncertainty, which is we just don't know enough. It's a sort of a lack of knowledge. It's, if you will, certain kinds of ignorance that hasn't figured things out yet. Or you can have ontological uncertainty, which
Yep.
is it is the way it is. Uncertainty is the thing. That's all there is. Um, and so I think much of science up until recently has been involved in a kind of epistemic uncertainty. They recognize uncertainty, but believe it's curable, believe
Yep.
eventually we could figure it out somehow or another. Whereas the ontological uncertainty that I think more science embraces now, is different. It recognizes that indeed it will always have a level of uncertainty and that turns out to be useful. I mean, these phones we have and GPS devices and lasers and randomized controlled trials use randomness, randomized controlled trials to discover drugs, right?
Absolutely.
And AI uses a certain level of randomness and uncertainty in its searching. Otherwise, it would, even as a computer, would take it too long to do some of the things it does. I suspect our brains, I don't know this because I'm a neuroscientist, but I don't know this. I'm quite uncertain about it. But I suspect our brains use a large number of random processes. Doesn't feel that way. Feels like we know what we're talking about. Like I've got this all planned out. But we don't. Andre Gide, a famous poet, the surrealist poet, once claimed that the speed of speech is faster than that of thought. And once you get past the jokes about politicians putting their foot in their mouth and all that, you realize it's true. I mean, we do speak much faster than we think. Well, I don't think a sentence out thoroughly before I say it. I just blab it out. That may be obvious. I don't know.
It
But
depends on what language you're talking in,
yes, yeah,
too.
that's also true. That's all. But you don't really know another language until you don't think your way through it, right? If you're translating, you're not really speaking that language. And so if that's the case, the brain must be operating on some fundamentally kind of random sort of processes that it puts together and chooses and then does what it does. But that's a whole branch of neuroscience we don't want to get into. So your question again was I think, how do we let the public in on this
Yes,
uncertainty business, right? That we consider it positive, not negative. And that I agree is probably the trickiest thing. So I don't have an answer to this. I wish I had an answer. Believe me,
fair.
if I had an answer, I would be, yeah. But I think there are some answers in it. I actually think, for example, the whole mis and disinformation, the pseudoscience versus real science debates. So, that issue has been going on among philosophers and scientists to some extent for more than a century. How do you tell real science from pseudoscience? How do you know that astrology is not real science when astronomy is? Um, I used to say, so, it's not flu season right now, but so at one time, astrology is based on the idea that our lives are influenced by the stars and the planets and their movements and all the rest of that. At one time, we also believed that the flu, which is called influenza, because it was believed that it was caused by the influences of the planets and the stars around us. Now, we know that's no longer true. But we also know from astronomy that the stars and the planets do influence some things like the tides. Why is that okay, but not our
Sure.
lives, right? So how do we make this discrimination between pseudoscience and real science? It's very tricky. A lot of philosophers have spent a lot of time on this. I don't want to pretend I've solved it, but I think current science and the uncertainty that current science embraces has solved it to some extent. Because now we can say that real science is uncertain, whereas phony science, pseudoscience, never is. It always has an answer, and it's always the right answer, no matter what it does. So astrology, always has the perfect answer for you, right? It doesn't
Of
give you a
course.
range of options or anything like that. It gives you some set of predictions.
But this actually raises an even bigger philosophical issue, which is science actually making us more optimistic?
Yes. The simple answer to that, in my opinion, is
Okay,
yes, it should be. Um, and I think it is. I think it generally still is. No matter, I mean, we say people now have a mistrust of science or they're suspicious of it, but I don't think that's really true. I still think science has a power among most people, even pseudoscience. The pseudoscientists, the charlatans out there, the imitators, the ones with the quick cures and all that claim that what they're doing is science. So they think science is valuable. They're just forgers. That's all. They're
of
just
course.
forgeries, right? And it's still in advertising, still probably the single best statement you can make in advertising is it's scientifically proven that our product is 99% better than the other schmoes, right? So we still use science as a way of saying this is good information, this is reliable, this is something good. So I think what's wrong is that we now have a population that maybe has a lot of wrong ideas about science that leaves them vulnerable to pseudoscience. So I don't think they don't like science. I think they respect science. They just don't know what it is anymore. And real science, being uncertain, leaves this gap for the pseudoscientists to jump in and give them certain answers that aren't really good answers.
So, if uncertainty is creating possibility, Does possibility in this case create hope?
Yes, so there are indeed philosophers, for some reason or another, prefer the word hope to optimism. I don't. I think hope is too passive. I think
Okay.
hope is kind of like, it's like Franz Kafka said, there is hope, but not for us. So, what can I say? Um, so, hope is kind of a passive, let's hope it gets better. We can be hopeful it'll probably be better or may be better. I think optimism is much more powerful. So, by optimism, I want to point out that I very distinctly do not mean a psychological disposition, a mood, a cheery kind of glass half full, rosy glasses, all of that optimism, self help crap, if you'll pardon
Sure.
me. So I mean a philosophical optimism. I mean a philosophical approach to the world that believes things could be otherwise, that we can look at something. And if you think about it, we are among the first of just a few generations. I mean, people with a brain this size have lived on this planet for 250,000 years. And it's only in the last couple of generations that we have been able to look at something and say, well, that could be different. It could be otherwise. We don't always get it right. Sometimes we mess it up, but most of the time, on average, we're getting it right. It's better. I mean, would you rather be sick today or 25 years ago? I mean, rather not be sick at all, of course. But if you're going to be
Yes.
sick, let's do it today, not 25 years ago, right? So in general, I say the kind of optimism that science brings is this philosophical optimism of possibility, of progress, of a belief in a future. Even the idea of a future is fairly new, believe it or not, because many worldviews, many cosmologies, many religions have a circular view of time that we're, going back to a beginning, a rebirth, a renaissance, all these other things. The idea of a linear time that goes out to an infinite future is actually also a new idea. As, by the way, just to finish this whole thing off, is optimism as a word. So people think optimism has been around for forever. But actually, the word optimism did not exist until 1759 when it was invented by Voltaire for his novel Candide or Optimism.
Yeah.
So we didn't even have the word. The idea, we had a vague idea things could be better, but it was mostly kind of resignation, not
Sure.
not true optimism.
And that's all for today's episode. If one thing should stick with you from this conversation, it should be this. The goal was never certainty. It was about asking better questions. And if this episode changed about how you think about what scientific even means, share it with someone who still thinks science should supposedly give them just one single right answer. So I'm Autumn Faneff, and this is Breaking Math. Stay curious and stay informed of the world around you. Until next time.